Alright guys, welcome back. Today we're going to be dealing with differentiation rules and rates of change. Our warm-up today though deals with something different. This should look like things from the very first unit. In fact, it should look similar to your formal definition of a limit. And that's going to be the limit as h approaches 0, the formal definition of a derivative of f of x plus h minus f of x over h. These are actually called derivatives in disguise. And now that we're learning how to take derivatives, it's much faster to recognize that this language here is asking you basically to calculate the slope of a function. And in this particular instance, you just need to determine what your function is. This first one is easy because the function, if you look at the layout here, your function is right there. If you look at where your f of x would be in this limit language, in this formal definition language. So really what I want is f prime of x, where f of x is x to the fourth. Well, that's going to be 4x cubed. Okay, on this second one, my function is here, so my function is sine x, so my derivative is going to be cosine x. All right, this one is a little more complicated because you don't see the complete limit language. You're missing this minus f of x, and you've also got, instead of x, you've got a pi over 2. This one is a little sneakier. It's actually asking you to take the derivative and evaluate it at a point. So I'm going to kind of change it up a little bit. Limit as h goes to 0 of cosine, let's get that erased, pi over 2 plus h minus cosine pi over 2. That's where the x would be, but we're evaluating at that point, over h. Well, cosine of pi over 2 is 0. That's why that's missing from this particular example. So really what I want is my function is cosine x, my derivative is negative sine x, and it wants that evaluated at pi over 2. Well, negative sine of pi over 2 is going to be negative 1. Okay, we're going to continue on with examples like we were doing yesterday, where we're relating everything to position, velocity, acceleration, and we're going to do some more examples of this. This is really big. It comes up a fair amount. We see it on the AP exam. It's a very fundamental concept that we deal with in calculus. Okay, so first of all, this language here, this is just telling us we're moving horizontally. Okay, and so this position is my x position along that horizontal with respect to time. And it also gave me a domain restriction for my time. So I'm going to find my velocity. My velocity with respect to time is going to be the derivative of my position. It's going to be my slope. So that's going to end up being 4t squared minus 18t plus 8, and the 4 goes away. And then my acceleration with respect to time is going to be 8t minus 18. Now, it wants my displacement. My displacement is asking what my position is relative to my starting. So my displacement in the first 6 seconds, first of all, I could have moved to the left or I could have moved to the right. Displacement can be negative. I'm not saying it is in this instant, but it can be. Okay, so that's important that you remember that because there's a difference between displacement and distance. So if I'm talking about position, I have to go back to my original position equation. Okay, if I'm asking about how fast or when it changes directions, I go to velocity. But any position question has to go back to your original position. Okay, I'm going to find in the first 10 seconds, so I know my times. So I need to find my position at 0, and I need to find my position at 6. I don't really care at this point about everything that happened in between. So x at 0 is 4, and x at 6, if I put the 6 into the original equation and evaluate it, take a moment to do that. Go ahead and hit pause so you give yourself time to do that. Okay, your position ends up being 16. That means my displacement is which way did I go and how far from my original position. My displacement in this problem is 12. Okay, now it wants me to think about when my particle changes directions. Well, what has to happen for you to be able to change directions? First of all, if I'm traveling along to the right and I want to change directions, I've got to stop before I can change direction and go the other way. Okay? Now, just because I stop doesn't mean I change direction. Okay? So keep that in mind. It's very, very important. I have to stop and change direction, which means my velocity has to go to 0, and, this is huge, and change signs. I could have, like this second example, I could have just been moving right, then stopped, and then continued moving right. So you do have to check the signs on both sides. So if I want to know when my velocity goes to 0, I set my velocity equation equal to 0 and solve. So 0 is equal to 4t squared minus 18t plus 8. I'm going to go ahead and divide everything by 2, just make it a little easier to deal with. So that's going to be 2t squared minus 9t plus 4. And then I'm going to factor that. I'm going to say this multiple times in this class. Everything you've ever learned in math comes back up in calculus. We just assume you remember how to do it. When you factor this, it becomes 2t minus 1 and t minus 4. So this happens at t equals 1/2 and t equals 4. Now that's when I've stopped. That does not mean that I have changed directions. So I'm going to check my velocity at 0 is positive. My velocity at, let's see, 1. Okay, so I have 0 to 6. And then I have critical values at 1/2 and at 4. So I need to check on these intervals. So at 0, I'm at positive. I'm going to just check the value at 1, velocity at 1, just because it's an easy number to put in. And that's going to be negative. And then at velocity at 5, when I put that in, I'm going to get a positive. Okay, so I did change signs, so I changed directions here. So notice I did acknowledge these are my critical values. This is a closed interval, so my closed interval is going to include my endpoints and then any time that my velocity went to 0 in between. Okay, so it changed at t equals 1/4 and 4, 1/2 and 4. Because velocity of time changed signs. Okay, and we're going to, just like with our limit language, we need to always include our reasons and our justifications.